Welcome to this session of finite element method. In this session, I will going to discuss about the concept of plane strain, my dear students. So, what is a plane strain? This is x direction, this is y direction, this is z direction. These are three principal directions, my dear students. The strain in one of the principal direction, either x direction or y direction or z direction, assumed to be 0. So that is called as a plane strain condition. In our case, strain in z direction is assumed to be 0 here. Now, the plane strain is a condition strain in one of the principal direction, that is either x or y or z direction are assumed to be 0. Assumed to be assumed to be 0. In our case, strain in z direction is assumed to be 0, my dear students. Now, this concept I will explain this concept by using a simple example, my dear students. It is a three-dimensional object here. Width of the object is W, length of the object is L, thickness of the object is T. Yes, my dear students. Now I am consider this is x-axis direction, this is y-axis direction, this is z-axis direction. This is z-axis direction. Now, in x direction, the dimension of the object is L. Y direction, the dimension of the object is T. In z direction, the dimension of the object is W, my dear students. When force is applied, x direction, y direction, and z direction, in all three directions, my dear students, at that time the deformation takes place in x direction, in y direction, in z direction, my dear students, so that the strains also produced in x direction, in y direction, in z direction. Okay, that things are already studied in stress strain relationship, my dear students. So because of the forces in all three directions, strains are also produced. So the strain produced in x direction is represented with epsilon x, that is epsilon x, so that epsilon x is equals to, all of see, my dear students, x direction dimension is L, so that what is the strain? Change in length by original length. Similarly, the strain produced in y direction, that is represented with epsilon z, that is epsilon y. The strain produced in y direction, that is represented with epsilon y, that is epsilon y is equals to, what is the dimension in y direction, my dear students? Thickness. So that change in thickness divided by original thickness. So similarly, the strain produced in z direction is represented with a letter epsilon z, that is epsilon z. So now here, what is epsilon z? Epsilon z is equals to, in z direction, that is perpendicular to my screen, that is width of the member. So what is the strain in this z direction? That is change of width to original width. All of you carefully observe, my dear students. Here the width is very large compared to length and thickness. So that here strain in x direction is equals to delta L by L. Strain in y direction is equals to delta T by T. Strain in z direction is equals to delta W by W. Here length is very less, automatically epsilon x is more. Similarly, thickness also less here. Thickness also less, so that epsilon y also more. Here is width is more, my dear students. All of you verify this one. Here is width is large compared to this dimension and this dimension, my dear students. So that width is large, strain in z direction is very small. So very small in this sense, it near to 0, that is tends to be 0. Epsilon z tends to be 0, my dear students. So in our case, strain in z direction assumed to be 0, my dear students. Excellent. Now, what is a plane strain condition, my dear students? In plane strain condition, one dimension is very large compared to remaining two dimensions, that is length and thickness. Here is width is very large compared to length and thickness, so that strain in width is equals to, that is nothing but strain in z direction is a 0. Clear? In plane strain condition, one dimension is very large compared to other two dimensions, so that strain in that direction here is, that is z direction, is assumed to be 0. Assumed to be 0, my dear students. Now coming to finite element method, strain represents, there are 3 normal strains and 3 shear strains. What are that one? Epsilon x, epsilon y, epsilon z, gamma xy, gamma yz, gamma zx, whole power transpose. These 3 strains are shear strains. These 3 strains are normal strains. Okay, my dear students. But in our case, the strain in z direction is 0. That means whatever the terms associated with, that is nothing but whatever the strain terms associated with z assumed to be 0. That is, it is a strain term in z direction is 0. This strain term is also associated with z, it is also 0. This term also strain associated with z, it is also 0. So the remaining strain terms are epsilon x, epsilon y, gamma xy, whole power transpose. This is called plane strain condition. Plane strain condition, my dear students. So, in plane strain condition, what are the stress terms, what are the strain terms are 0, what are the stress terms, what are the strain terms are not 0, I will write here. So, epsilon x not equals to 0, epsilon y not equals to 0, gamma xy not equals to 0, sigma z also not equals to 0, my dear students. It is a very important. Now here, what are the terms with 0? That is gamma yz 0, gamma zx 0, tau shear strains yz 0. Sorry, these are the shear stresses. These are the shear stresses. Sorry, these are the shear stresses. Shear stress in yz plane 0. Shear stress in zx plane 0. So, these are the conditions for plane strain, my dear students. Excellent, my dear students. Here, it is another example. It is a dam, my dear students. Length of the dam is L. Thickness of the dam is T. Width of the dam is W, my dear students. This width is very large compared to these two dimensions, so that strain in z direction, that is width direction, is 0. Now consider, we are already studied stress strain relationship matrix, my dear students. In that, strain in, when force is applied z direction, strain in z direction, when force is applied, that is this direction. So whatever the strain produced in this direction is longitudinal, remaining two directions, x direction, y directions are lateral strains. That is here sigma z by E minus mu times sigma y by E minus mu times sigma x by E. Now here strain z is equal to 0, so that sigma z by E, I am substituting z is equal to 0 here, minus mu by E into sigma y plus sigma x. Sigma x, my dear students, these are x. Now from this, sigma z is equals to mu times sigma y plus sigma x. It is a very, very important. In plane strain condition, the stress in z direction is not 0. That is very important, my dear students. Now, coming to, we are already studied stress strain relationship for three-dimensional objects. Stress strain relationship for a three-dimensional object, my dear students, that is sigma x, sigma y, sigma z, tau xy, tau yz, tau zx. That is equals to E by 1 plus mu into 1 minus 2 mu here it is epsilon x, epsilon y, epsilon z, gamma xy, gamma yz, gamma zx. Yes, matrix is 1 minus mu, 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 0, 0, 0, mu, 1 minus mu, mu, 0, 0, 0. Here is mu, mu, 1 minus mu, 0, 0, 0. Here is 0, 0, 0, 1 minus 2 mu by 2, 0, 0. Here is 0, 0, 0, 0. This term is 1 minus 2 mu by 2, 0, 0, 0, 0, 0. Here is 0. The last term is 1 minus 2 mu by 2, 2 mu by 2. This is 1 minus 2 mu by 2 last term. Here this is epsilon x coefficient. These columns are epsilon x coefficients, these columns are epsilon y coefficients, these columns are epsilon z coefficients, these columns are gamma xy coefficients, these columns are gamma yz coefficients, these columns are gamma zx coefficients. Now here in plane strain condition z is equals to 0, so that we are eliminating this row. Again yz, whatever the terms associated with, whatever the strain terms associated with z, that is also we are eliminating like this. Again this term we are eliminating this one. Similarly columns also. So whatever the column associated with z, this one we are eliminating this one. Again similarly we are eliminating this column. Again we are eliminating this column. What are the remaining terms here, my dear students? Here is the remaining terms left here. This one, this one, and this one. This one, this one, and this one. Here this one, this one, this one. Okay? So here is sigma x, sigma y, tau xy, that is equals to E by 1 plus mu into 1 minus 2 mu. Here 1 minus mu, mu 0, mu 1 minus mu, 0, 0, 0, 1 minus 2 mu by 2, my dear students. Here the terms left, strain terms left here, that are epsilon x, epsilon y, gamma xy. Now this matrix is called as a D matrix, my dear students. It provides relation between stress and strain. So, in plane strain condition, this is a D matrix, my dear students. So, I will write here. In plane strain condition, that is in 2D analysis, D matrix is given by 1 plus mu into 1 minus 2 mu. Here is 1 minus mu, 0, mu, 1 minus mu, 0, 1 minus 2 mu by 2. So, wherever in case of 2D analysis, the plane strain condition, the D matrix must be this one. D matrix must be this one, my dear students. Thank you.